Good morning, friends. I am here again for the course, which is Aircraft Systems. Today I am in lecture number 19, and my topic of the day is Principal Components and Types of Aircraft Hydraulic Systems. I am Dr. Yagya Dutta Dwivedhi, Professor from Institute of Aeronautical Engineering, Hyderabad, India. In today's lecture, I am going to discuss about warning status, emergency power sources, yellow and the green systems, yellow systems, emergency systems, then green system and standby PTU. In previous classes, we have discussed about hydraulic systems and its components, hydraulic pumps, characteristic curves for a constant pressure pump, working principle of a hydraulic pump, fluid conditioning, and the reservoir. This we have already covered in previous lectures of hydraulic system. You know that in aircraft we need to fly the aircraft, and to fly the aircraft we need the control surfaces. For taking off we need landing gears. For landing also we need the landing gears. All the flight controls like elevator, aileron, rudder, and the landing gears has to be operated by the help of the hydraulic system. Because if the hydraulic system is not there, pilot has to apply the forces which are always engaged, and lot of energy is consumed from the pilot, and pilot will get tired. To avoid that, the hydraulic systems are used so that the pilot can operate the system by applying a very small amount of forces, and the feedback which is received from the control systems are also reduced to a minimum level, so that pilot will only have a feel of control surfaces but not the real load which he is supposed to get if it is not the hydraulic system. In our previous classes, I have discussed about the hydraulic system, and we have seen a typical hydraulic system consists of the reservoir here. This you can see, this is the reservoir. Then we have the here one pump, and these pumps are mostly the gear type of pumps. Gear pumps, most of the aircraft we use, they are very small, just you can see here. This is here. So this you can see. Then after this pump, the hydraulic fluid has to be filtered. Otherwise, if it is entering a dirty fluid or the contaminated fluid is entering inside this actuator, actuators are very smooth, and they may cause the damage in the actuators. So the bigger particle, more than 5 micron, the capacity of this thing is 5 micron. So if any particle is more than 5 micron, this will be restricted in this filter. From here it goes to the check valve. In the check valve, the purpose of this check valve is to make sure that the fluid is going into one direction, and that is from pumps towards the actuator, not in this direction. That is not permitted. So this is done by the help of this check valve, or it is also called the non-return valve. And from here it goes to a shut-off valve. This shut-off valve is used to make the system on and off. And from there it goes to the pressure reducing valve. Here the pressure as per the requirement of this actuator. Suppose this pump is pressurizing up to 3000 psi, but our actuator needs 2000 psi. So this pressure reducer will reduce and the excess pressure will be released. So that is the purpose of this. And after this we have the selector. The selector makes the system to work either in this direction or in this direction as per the requirement. So in this way actuators are working, and they will move left or right, and here your aerofoils are connected from elevator, rudder and other component, and these things will move as per the requirement of the system. Then we can see here that after this actuator, the fluid is again moving towards the reservoir, and before entering the reservoir, we should have one more filter here, and this filter will again the 5 micron, and it will try to restrict any material chips or metal particles or any other impurities which after operation may have happened, may have to stop here. Another very important component is the accumulator. This accumulator is the yellow color. It is the hydraulic fluid here. This is the hydraulic fluid, and this is the nitrogen here, or the air, but mostly we use the nitrogen, and it is a non-corrosive and it is a non-fire. Means fire will be prevented by the nitrogen, but if we use the air, the chances of the fire is always present. Next we have here this gear type of pump. This you can see here, the fluid is entering from this side. It will go to the both the direction. From here it will go here, 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 and it will go here, and same way it will go here and it will go out. And here you have the high pressure, okay, high pressure, and here you have the low pressure. So the purpose of this gear type of pump is to pressurize a medium pressurization with a very smooth flow. It gives, and a continuous flow of fluid is maintained by this type of gear. So here we have one is the driven, and by this the driving, it is a driving, so it is fixed with the engine, and the engine output is connected here, and it will try to rotate this, and due to this rotation opposite direction, another driven gear will also move. So this is the principal function of and how it is working. I have just explained, and these things are already explained in my lecture number 18. Another very important component is the hydraulic tank. We know that if any hydraulic tank, if it is just like a container, and if the aircraft is moving here and they are doing the maneuvering, different maneuvers like this, so this hydraulic fluid will be sloshing. It will go here and there. To prevent that, we have to design the hydraulic system in such a way that there should be some fins. There number of fins are there, and in between the fins we have the baffles. So the fluid is restricted. It will not go all of a sudden, and a very smooth transition from upper to lower and lower to upper will be there. Here we have one filler cap here. From here the hydraulic fluid is entering, and from here it is a vent. So if any air particles are there, it will be going from the here. So here is a finger strainer, a very small strainer is also here. So bigger particle will be accumulated here, and then here we have the connection for the emergency system pump here, and then connection for the main system pump. So here emergency is here and main is here. So like this we have here a glass side. So from here we can see the fluid level. If the level is less than this, we have to fill this thing and make sure that it is in the maximum level always. We should try to make the hydraulic level in the tank as maximum as possible. Now there are some very important other components. One is the accumulator. You know that accumulators are very important, and they are like a reserve bank. You keep your money in a bank, as and when you require you can take back, and if you have the extra money you can deposit in the bank. So here if you see here we have the hydraulic fluid in the upper side. It is a hydraulic fluid, and here we have the nitrogen, and here is the diaphragm. So it is pressurized. The hydraulic fluid is coming from the top, and nitrogen is charged from here, and it is as per the pressure of the system. Nitrogen, if the system is or the pump is operating at the 3000 psi, nitrogen will be charged up to 3000 psi. So it will, as and when here the pressure is reducing, it will pump to this side, and if the pressure is high, it will come back here. So it will always maintain a constant pressure of the system, and the hydraulic system will operate. If the hydraulic pump is not working properly, or the system is having some pump problem, this accumulators will supply for the time being, and also it will act as a accumulator. the excess fluid will be entering inside and it will restore in this. Another type of this thing is also here. So hydraulic fluid as same way. Next are the filters. There are number of filters I have shown in the previous, that one is after the pump and another is before the reservoir. So after we need some filters. So what happens? The filters, the hydraulic fluid is moving from here, just you can see, and there is a filtering element here. So the unnecessary particles or impurities are trapped inside this filter here and here, and the pure hydraulic fluid will enter in this and it will go to the next component from here. But if this filter element is trapped and it is clogged, then what will happen? The pressure will increase in this chamber and this will try to lift this knob, and this here it is indicator button and the red button will be visible if this thing is clogged. Here we have the thermal lockout and here we have the magnetic plug. This magnetic plug is making sure that there is no damage to the gear pump, because most of the gear pumps are made from the ferrous material. So if the material is damaging or some wear and tear of the material is taking place in this system, the material, chips will be trapped and the system will be blocked. Next is priority valve. So the priority valves are used to give the priority as per the requirement. If there is an emergency and we want to operate the hydraulic system of landing gear, or we want to operate only the flight control system, if other systems we don't want, so this valve will give the priority as per the pressure available in the system. If the pressure is less, so only emergency system will be operated. So here from the pump, and here if you see secondary systems and the primary system, this will give only to the primary system here. Primary system. So in case the pressure is not sufficient, this system will be off and only this system will work. So this is the function of the priority valve. This will give the supply of the hydraulic fluid of a given pressure to the required emergency systems only. In case of the pressure and the amount of fluid is not available in the system. Next is the sequence valve. This valve is used to give a proper sequence, in which sequence the system to operate. So here it is a inlet and here is a piston, here is a spring. This spring and the pressure, the piston will operate and the fluid will move from here to here, and this is the inlet and here is the outlet. So as per that, it will give as per the requirement, the sequence of these things will follow. Now I will talk about the warning and the status. Several instruments are fitted to ensure performance of the hydraulic system. So first and foremost is the pressure transducer. This monitors system pressure and transmit this signal to gauges in the cockpit. Pressure switches are also incorporated to provide a warning of low pressure in the system on the central warning panel. Filter blockage indicators show the condition of the filter element to ground servicing personnel, and to fluid temperature warning may be given to the air crew. Use of microprocessor based system management units. More in-depth health monitoring of all major components is possible with data displays to ground crew on maintenance data panel. Accumulators, I have just now explained very in detail. This you can see the accumulators are here. These are the accumulators, and I have shown you that they are like a bank. You have to deposit your money as and when you want money, you can withdraw. So if you have excess money, you can put it. If you have less money, you can take it. So same function is done by the accumulators. Gives emergency supply for canopy, wheel brakes, flight control systems. All emergency systems are operated by the help of the accumulators. To supply emergency power for longer period, an electric motor driven pump may be provided. battery size and the weight are the main limitation in this case, and to minimize these factors, the flow available is usually kept as low as possible to operate only those devices considered indispensable. Only emergency requirement are operated by the accumulators. Weight may be kept to a minimum by the use of one short battery. So we should use the battery in such a way that only one time it can operate. Weight may be kept to a minimum by the use of one short battery. I think this is repeated. Hydraulic pumps and or emergency electrical generator can be mounted immediately behind the turbine on the same shaft. This hydraulic system I have shown here for the British Aerospace Equipment System, a company. It is called the BAE. So a full hydraulic system is shown in this diagram. This shows the full hydraulic system, and this you can see here. Here is your nose part, and here is the engine 2, and here is the engine 1, engine 2, engine 3, and here you have the. So here this you can see that a roll spoiler and DC pump, electrical AC pump, engine pumps, electricals. These things are operated, and in this way your systems of hydraulic systems are working. Now we have some other type of systems. Those are called the yellow and the green systems. In aircraft, normally we use the two types of systems, but in some aircraft we use the yellow, green and blue also. So and normally if you see, the systems are designed yellow and the green. I have shown here with the same color of the ink. So two types of systems, and are normally pressurized by a self-regulating engine-driven pump on the inboard engines. The systems are designed by a self-regulating engine-driven pump on the inboard engine. Each system has an independent hydraulic reservoir pressurized by regulated air bleed from its respective engine. So normally pressurized by a self-regulating engine-driven pump on the inboard engines. Each system has an independent hydraulic reservoir pressurized by the regulating air bleed from its respective engine. The yellow system is on the left side of the aircraft and the green on the right. Backup power for the yellow system is provided by the AC electric pump. So here, this we can see, the yellow system is on the left side of the aircraft and the green is on the right side. Backup power of the yellow system is provided by an AC electric pump. So it is, backup is given by the electric pump also. And backup for the power for the green system is provided by a power transfer unit. Power transfer unit driven by the yellow system. Okay. So the yellow system is also operated not only by engine but also AC electric pump also. But the green system is also operated by the power transfer unit, which is connected from the yellow system. If the yellow system fails, the power transfer unit is operated and the green system will start working. An electrically operated DC pump fed from a segregated hydraulic supply provides energy lowering of the landing gear and operation of the brake in the event of failures in both the yellow and the green systems. The primary power generation components of the yellow systems are engine driven pump EDP on number 2 engine. So what are the primary power generation component of the yellow system? Engine driven pump on number 2 engine, standby AC powered hydraulic pump, emergency DC powered hydraulic pump, accumulator and the reservoir. So these are the power generation component which are very much required for any yellow systems to be operated. Now green system, the yellow system power the following services: flap, one flap motor, flap asymmetry brake, roll spoilers, 2 lift spoilers, inner spoilers on the left and the right wing, one rudder servo control, standby fuel pump, left and right, landing gear emergency lockdown, wheel brakes including park brake, air steer through the AC pump, and power transfer unit. So these are for the yellow system. Yellow system component in the hydraulic bay. So here it is shown the yellow system. These are the accumulators. This you can see. These are the accumulators, very big tanks here and here. And from here, this will go to the actuator and different pipelines. Lot of valves are here. And this accumulators are charged here by the nitrogen. So these things can be done. And number of items and equipments are there on the aircraft. And this is the hydraulic bay here, below the fuselage here. And here is the avionics bay, and these are the wings, these are the engines, and these are the landing gears. Okay, so it is just depicted for the just sake of knowledge that where is the location of the system and hydraulic system. In this yellow systems component of the hydraulic systems are shown. Now, yellow system emergency. So if the yellow system fails, so what type of emergency and what the systems we have to follow. So if emergency is there, then we have to operate the backup DC pump. Backup DC pump is used. So yellow system reservoir, the reservoir incorporates the following: a pressure gauge, a side glass, an air low pressure switch, inward and outward relief valve, a bursting disc to protect against manual failure of the outboard relief valve, a ground charge connection and a manual pressure release lever, a contents transmitter. So next component is engine driven pump. It is called EDP. The yellow system engine driven pump EDP is mounted on the left inner engine auxiliary gearbox at the bottom of the engine to ensure easy maintenance access. It has motorized isolation valve. When the valve is closed, it isolates the pump from the tank and provides an idling circuit to offload the pump. If the engine fire handle is pulled to its fullest extent, the valve closes automatically, preventing more fluid reaching the pump. Okay, so in case of emergency, the yellow system engine driven pump is starting, and it is mounted in the engine auxiliary gearbox at the bottom of the engine to ensure easy maintenance access. Okay. Now the green system, I will talk about this green system. The primary power generation component of the green systems are engine driven pump on number 3 engine, power transfer unit PTU, hydraulic reservoir, and the accumulator. So if you see that in that and this, in this you have, these are the systems which are operated. Okay. So engine driven pump EDP on number 3 engine, power transfer unit, hydraulic reservoir, and accumulator. All components except for the engine driven pump are located in the hydraulic equipment bay. I have shown the hydraulic equipment bay. This is the hydraulic equipment bay. Other than engine driven pump, every items are fitted in the hydraulic equipment bay. So all green systems power the following: one flap motor. So what are the equipments operated, or what are the aircraft components which are operated by the green system? So in the one flap motor, 4 lift spoiler, center and outer spoiler on the left and the right, air brakes, landing gears normal, nose gear steering, and wheel brakes excluding park brake. Parking brake is not in the green system. So these are the things which are operated by the green system. So one flap motor, 4 lift spoilers, then air brakes, landing gears normal, nose gear steering, and the wheel brakes. These are the used by the green system. Green system is standby power transfer unit. The power transfer unit, okay, what is this power transfer unit? This is the yellow system and this is the green. Just I am writing green and the yellow. So there is this is called the PTU. So if this system fails, then this starts supplying from here to here. So if this is the system which will connect green to yellow and yellow to green. So that is the purpose of the power transfer unit. The power transfer unit is an alternative power source for the green system. The PTU is a back-to-back hydraulic motor and pump. It can support all green system services except for the standby AC/DC generator. The motor is provided by the yellow system pressure and is connected by a drive shaft to a pump in the green system. The PTU is controlled by a 2-position switch. So here there is a switch in this. So on or off. So if you make here, it is on. If you make here, it is off. So it is on off. It is like a shut off valve. When the switch is on position, it is automatically activated if green system pressure falls below 2600 psi. With the switch is in the off position, the motor is isolated from the yellow system by the motorized valve. So if the system is pressure is falling, the green system is falling 2600 and below, your valve will open and the yellow system will start supplying, the motor will start supplying to the green system. The PTU may be used during ground servicing to pressurize the green hydraulic system provided the hydraulic reservoir is fully charged with air. Okay, on the ground, this PTU is used for the maintenance purpose for the system's operation in the ground, and this can be operated by the electrical pump. Green system is standby AC and DC generator. The green system hydraulic system can be supported the electrical system in the event of low electrical power. A standby AC/DC generator driven by a hydraulic motor is powered by the green system and is controlled by a 3-position switch on the flight deck overall system. The generator can be selected on or off manually, but is usually in automatic standby or arm mode. The generator is normally isolated from the system pressure by a solenoid operated selector valve. When the standby AC/DC pump is operating, its selector valve is opened, and at the same time, green system services are isolated by their shut-off valve. Green system services are therefore not available while the generator is operating and the green system low pressure annunciator is indicated by a white light on the overhead system of electrical panel. Green system reservoir and accumulator. The green system reservoir has the same capacity as the yellow system and is charged with bleed air from number 3 engine. Its features are exactly the same as the yellow system reservoir. So I have seen this reservoir. If you see here, I have shown the reservoir here. This you can see how these reservoirs are made. So here it is pressurized, and this pressurization can be done by the help of the engine bleed, so that it should not work. So the green system reservoir has the same capacity as the yellow system and is charged with bleed air from number 3 engine. Its features are exactly the same as the yellow system reservoir as I have shown earlier. Next is accumulator. The green system accumulator is identically to the yellow system accumulator. It maintains stability in the green system during operation of the PTU and also assists the engine driven pump for initial run-up of the standby AC/DC generator. Okay, so what is this purpose? First thing is it is stabilizing. Stabilizing, the first purpose. Okay, and the green system and operation of the PTU. So whenever you operate the PTU, this is the PTU, this is the green, and this is the yellow. So during this operation, there will be some fluctuation of the hydraulic power. So if this is accumulated by accumulator, it will give the supply and fluctuation will be reduced. And also assisted the EDP when the engine driven pump is working for the initial startup of the engine. Your AC and DC generators, when they are starting the engine and the engine driven pump may not able to supply a sufficient amount of flow and the pressure, that time, for instant of time, your accumulators are used to make a very smooth flow of the hydraulic fluid. Now I will discuss here Airbus 320 hydraulic system. The Airbus 320 runs on 3 separate hydraulic systems, which in emergencies can be combined to perform as one. The 3 different systems are the green, yellow and blue. So in Airbus system, we use the 3 types of hydraulic system, and they are separately, and as and when in case of emergency, these systems can be operated as a collectively as a one. So they are divided as per the color. First one is the green, then yellow, and the last one is the blue. So in the green, what are the components which are operated by the green hydraulic system? Slats and flap, landing gear, engine 1 reverser, normal brakes, yaw 1 damper, stabilizer, and certain flight controls. So these are the operated by the green. These are all the components. So they are the slats, flaps, landing gears, engine 1 reverser, normal brakes, yaw 1 damper, stabilizer, and certain flight controls. Now if I talk about the yellow system has got the flaps, parking brake, yellow 2 damper, engine 2 reverser, rudder, stabilizer, and nose wheel steering. So these are the 1, 2, 3, 4, 5, 6, 7. These 7 components are operated by the yellow system. So first one is the flaps. Second one is the parking brake. Yaw 2 damper. Here in this, yaw 1 is operated by the green, but yaw 2 is operated by the yellow. Engine 2 reverser, rudder, stabilizer, and nose wheel steering. This one is not in the before. We have just seen the yellow and the green, but blue one is also used, and they are used for the slats, then rudder, emergency generator, and some flight controls. So these 1, 2, 3, and 4, these things are used by the blue hydraulic system. So I think we can understand that the green, yellow, and the blue hydraulic systems, they are operating the different systems, not the same. So for the green, it is slats, flap, landing gears, engine 1 reversal, normal brakes, yaw 1 damper, stabilizers, certain control flights. Yellow operates with the flaps, parking brake, yaw 2 damper, engine 2 reverser, rudder, stabilizer, nose wheel steering, and the slats, rudder, emergency generator, and some flight controls are used by the blue system. Now green, white, blue modes of operation. How these things are operating, that I am going to discuss in the following slides. The green and yellow systems are engine driven, while the blue system is electrically driven. So that is the two, green and yellow, they are operated by the engine, but this blue system is operated by electrically power, by electrically motor, and by engine number. So the yellow hydraulic system is pressurized by the pump driven by engine 2. Yellow system by engine 2. And electric pump can also be pressurized, the yellow system, which allows yellow hydraulic to be used on the ground when the engines are stopped. So during ground for the maintenance work, an electric pump can also be pressurized, the yellow system, which allows yellow hydraulic system to be used on the ground when the engines are stopped, Crew members can also use the hand pump to pressurize the yellow system in order to operate the cargo door when no electrical power is generated. So if you want to operate the, like, this is the your aircraft and here is a door. So if you want to operate this door, there is a hydraulic hand pump like this. So this you have to press like this and this will be opened. So this you can use a hand pump, and this is a hand pump, and your air crews can use by to open the doors of the cargo doors or the passenger doors of the aircraft. Aero system in order to operate the cargo doors when no electrical powers are available. Now, if I discuss about Airbus 320 hydraulic systems used for the flight control. So here, this we can see here, green, yellow, blue, yellow, green, green, yellow, blue, green, yellow, right, and here is the, so this you can see here, it is mentioned for roll is used this two, and this is the blue here. Speed breakers are used by these yellow systems. If you see here the rolling yellow system, speed breaker, these all things are shown here, and these are all are situated in the your wings of the aircraft. Airbus 320 control operation. This we can see here that elevators, how these elevators are operated. Elevators we have here yellow and the blue, and here we have the green and the blue. Okay, so this is the left side and this is the right side. Right side is operated by the yellow and left side is by the green, but this operated by the blue. So the right elevator, both elevators, the last one, if you see here, a wing, so this I am drawing the wing here like this. This is the wing. So this is the tail. It is not the wing, it's just I will show you. So this is the aircraft, and here is the tail, and this is the wing. So here we have the elevator here. So this is the right side, and here is the left side. So here we have the two parts. One is operated, the inner one is operated by the green, and this right is operated by the yellow, and this tip are operated by the blue. So this is the elevator operation, and here also this is 1, 2 and 3 electrical motors. Here we have the clutch, and this is the mechanical control. So here this we can operate by this, the hydraulic motors, green and yellow. Next we have the rudder. The rudders are operated, just you can see, by the green upper one, then the yellow and blue. All the three systems are used here, and in this way it is operated. Slides are also used by the blue and the green. The left side and the right side is by the right side flaps are used by yellow and the green. So in this way we use the our systems to see that it is working properly. Now this is the right side, this is the left side. So here green reservoir and here the yellow reservoir. And what is the difference? This you can see here. The reservoir is same. Here we have the engine 2 fire shut-off valve. Engine 2 pump is there. Here is AC2 pump is also. This is the electrical pump. And here we have the hand operated pump. So here we have the three type of operation in the yellow system. But if you see here, we have the engine 1 fire shut-off. It is here also and here also. Engine 1 pump, engine 2 pump, but it doesn't have these two systems are not there. That is the electrical pump and the hand pump are not there in the green system. If you see the blue system, blue systems are used. Here we have the reservoir, and here we have the, because this is used for the emergency purpose. So this ram air turbines are lowered, and this turbine is operating this pump, and these blue systems are working, and electrical systems are also there. So this both systems, they are operated by the electrical system. Here also it is turbine is operating, but it is giving power, and it is motor is operated. So this is a full system of Airbus 320 hydraulic system. In this way, your systems are working. If you see here that green user and the blue user and the yellow user, this you can see here. Here is a hand pump. Here is your, if you see this one, AC pump. This is the AC pump, and this is the normal pump. And here it is a power transfer unit. Here is the right turbine, right, and this will operate, and this will operate this AC pump. So 3000 psi, 3000 psi, 3000 psi. This goes for the yellow user systems. This goes for the blue user systems, and this goes for the green user system. So in this way, it is working, and these three types of systems are used for hydraulically operated systems. Now we can see the cockpit of Airbus 320, and here this you can see the green system is here, blue is here, and yellow. It will be displayed on the screen and in front of the pilot. And here we have the right main on. If you make the right on, in case of this blue system will start working. Here is automated yellow systems and the green system. Here also hydraulic system green, blue and yellow, and this will be visible on the system that which one is operating. This is the one, this is the two. Here is electrical system. This pilot will be able to see like this in his cabin, in his or her cockpit. Okay, so in this way we can see here, and these are the references. I am using the aircraft, this Moyer and Seabridge aircraft systems and mechanical, electrical and avionics system. They are the very good book. And another book is Design and Development of Aircraft System and Introduction. And these two books are very useful. And also I am referring some YouTube videos, and all this I have taken from the YouTube video. This also I have taken from the YouTube video. So in this way, we should, I am trying to express this idea. And at the last, but not the least, if any questions you are there, you can ask me. It will be my pleasure to respond. And my email is yddwivedhi@gmail.com. Any questions you can ask. Also, I request to subscribe the channel, like, so that any new videos are coming, it will be reflected to you. Thank you very much for joining the class, and please be for my next class. I am going to discuss about the next class. Okay, so thank you very much for joining the class.
Like, share and subscribe. Hit the bell icon for more updates.